Hi, I'm Maggie, and this is Music Theory for Piano Technicians, Part 18, Naming Partial Ratios. In my last video, I used scale degree numbers to explain coincident partials. And a quick review: 1, 1, 5, 1, 3, 5, flat 7, 1, 2, 3. I mentioned we didn't need to go past 8 much, but I'm going to 10 for these videos. In this video, I'm going to do something similar, but we're going to use the partial number. So I'm going to number them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you will have to remember this part, the 1, 1, 5, 1, 3, 5, flat 7, 1, 2, 3. You have to remember that in relation to the partial number. So quick review, this top keyboard, I'm going to write the harmonic series partials by scale degree, and that's 1, 1, 5, 1, 3, 5, flat 7, 1, 2, 3. In my second keyboard, I am going to write the harmonic series partials by partial number, and it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 through 10 is easy. Remembering where they go is a little tricky because you have to remember which one is which partial number. So it might be good to practice that. Let's use our F and C again, and I'm going to create a chart that lines up partials for you to give you a visual aid when thinking about this. I will tag that onto the comment section of these videos. So let's start from C, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this part is basically the same as what I did in my last video, and we're going to go up an octave. 1, 2, 3, 4, 5, and we really don't have to go up past 5. Now, I'm going to add something here. You may wonder, why am I doing this? Why am I not using the partial numbers? Isn't that easier? Well, sure it is. But there's something important we're going to discover here with our coincident partials that I went over in my last video, but I'm going to circle them again. And I would like you to notice something. These partial numbers give us the exact ratio between where the partials from one note can become a unison with the partials from another note. So right here, we have the second partial of our lower note lining up with the fundamental first partial of our upper note. This gives us a 2 to 1 octave if they are in unison. If we put into unison the fourth partial of our lower note with the second partial of our upper note, we have a 4 to 2 octave. Now when I say lower note and upper note, remember I'm referring to the note on the keyboard. I'm not referring to the direction up and down. I'm referring to pitch direction, a lower pitch and a higher pitch. So the sixth partial from our lower note could be made into unison, could line up with the third partial of our upper note. And if we did that, that would give us a 6/3 octave. We could also have an 8/4 octave, and if we wanted, we could have a 10/5 octave. The reason you can't line all these up at the same time, I will be explaining in a future video about inharmonicity and the harmonic series itself. It's a spiral. It doesn't do exactly what you think it might do, as I've mentioned in a previous video, and I will explain more of that soon. But for the moment, just know you cannot line all of these up all at the same time on a piano. Let's do this again starting from F. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Going up an octave, we have 1, 2, 3, 4, 5, and I'm going to stop there. Our coincident partials are here, 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 and here. If we make the coincident partials at this F into a unison, we have a 2-to-1 octave. If we make the coincident partials at this F a unison, we have a 4-2 octave. If we make the coincident partials at this C a unison, we have a 6-3 octave. If we make them a unison at this F, we have an 8-4 octave. If we were to make the coincident partials at this A unison, we would have a 10-5 octave. I'm going to explain how to do this in another video. Don't worry about that right now. Let's look at a fifth. We can start from our C again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A fifth up from C is G. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I don't need to go higher than that. Our coincident partials are here, here, and here. If we tune our fifth so this coincident partial at this G is in unison, which we typically won't do, but if we were to do that, we would have a 3-2 fifth. If we were to tune our fifth with a unison at this G, we would have a 6-4 fifth. If we were to tune our fifth with a unison at this partial, at this D, we would have a 9-6 fifth. Since we typically don't tune fifths, fourths, and thirds, and sixths pure, I'm just going to go over the concept of each one right now, but starting on C only. So if I look at a fourth, let's write our harmonic series for C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm also starting from C every time because the better you know the partials up from C, the easier it is to remember the rest of them. I can explain why another time, but for now, just take my word for it. If I look up a fourth, I'm going to start on F here. 1, 2, 3, 4, 5, 6, 7. Don't need to go higher. My coincident partials line up at this C, but to find more, I'd have to go higher, and we're not going to do that. Notice there's only 2 that line up with a fourth. A fourth is less consonant than a fifth. If I were to tune my fourth to where the coincident partials at this C became a unison, I would have a 4-3 fourth. If I were to tune this fourth to where I had a unison at this partial, at this C, I would have an 8-6 fourth. Now let's look at a major third. So I'm going to start on C again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A major third up would be E. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't have to go higher. Our coincident partials are here, here, and here. And notice these two are very close together. That creates an interesting quirk I'll share later. I'm going to pause my video here because when I originally made this, I went on autopilot and I made a mistake. This 9-7 coincident partial right here, this one, that's technically not a coincident partial. Yes, that falls on a D if we use the pattern I've been trying to teach everyone. And yes, this falls on a D. However, these are 2 different harmonic series. And do you remember when I said that the harmonic series gets smaller and closer together as it goes up? These aren't the same D. In particular, this one right here, this 7, that is going to be ridiculously flat. Well, maybe not ridiculously, but pretty flat compared to the 9 up here. And so while they do both fall on a D on our keyboard, remember the harmonic series is not equally tempered. This 7 is going to be over here by quite a bit, and this 9 will be close to where it is, but just a hair sharp. But this 7 is going to be way flat. So if we were to line up the harmonic series not on a keyboard. These would not line up so nicely. Another point I would like to make is that the harmonics that do line up very close to each other are going to be the ones that are multiples of the original ratio. 5 by 2, you get 10. 4 by 2, you get 8. So this 9/7 kind of doesn't belong here, but I'm going to mention it again in a minute. For the moment, I'm not going to take anything out of my original video. I'm going to let it play, and I will come back in a minute. But if we were to tune our major third at a pure point with a pure unison at this E, we would have a 5/4 third, major third. If we were to tune a unison here at this D, we would have a 9/7 major third. If we were to tune it with a unison at this E, we would have a 10/8 third. So even though we wouldn't be using a 9/7 coincident partial because they're so far apart, you could create a 9/7 major third. It's feasible because that 9th and 7th partial are still closer together than all these other partials over here and elsewhere are. They're not close, but they're not that far. So if we took this very flat 7 and we raised E enough to bring this 7 high enough to actually line up with this 9th partial, we would have a 9/7 major third. However, if we did that, it would be very hard to do orally because the 5th and 4th coincident partials and the 10 and 8 coincident partials would be beating very, very fast. And the 5/4 and the 10/8, they'd be beating very fast. We wouldn't really be able to hear this 9/7 very well. And on top of that, this E would sound very, very sharp to Western ears. It would not be practical at all. So once again, for equal temperament, for tuning purposes, this 9/7 almost coincident partial should not really be considered a coincident partial. Having said that, we can move on. Moving on to a 6th, starting from C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A major 6th up from C is a 1, 2, 3, 4, 5, 6, 7. I don't have to go higher. Our coincident partials line up here and here. So if I were to tune this major 6th and put the partials that meet at B in unison, I would have a 5/3 major third. If I were to tune it so the partials at this E lined up in unison, I would have a 10/6 major third. Just for fun, let's do a minor third. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A minor third up from C is E flat. So we have 1, 2, 3, 4, 5, 6, 7, 8, and I don't have to go higher. Our coincident partials are here, here. So if I were to tune a minor third with a unison at this D, I would have a 6/5 minor third. I'm going to stop my video again because I made the same error with my minor third that I did with my major third. I just went on autopilot and started circling coincident partials. So this 7/6 coincident partial is not actually a coincident partial. We use the same key because that's how we learned the harmonic series, but we're learning that harmonic series equally tempered, and it's not, and we always have to remember that. So I made that mistake again. My bad. The coincident partial 6/5 is real. It is actually there. The next coincident partial would be a multiple of that. It would be 12/10, and it would be up higher, a little too high to use. So for our purposes, stick with this 6/5 partial, which is also the ratio of a minor third. It can be extremely useful. So I'll let myself continue in my video even though I'm a little off. I still hope it's helpful. Here we go. I'm going to talk a lot more about how to tune these intervals later. I hope this gives you a better understanding of coincident partials and how we name them with their ratios. The ratio is basically how many parts from the lower number compared to how many parts from the upper number. So 6 parts of the lower number to 5 parts of the upper number, the divisions of the string. I will attach a link that takes you to my accompanying handout. And if you have any questions, because there's a lot I left out of this, please feel free to email me at maggie@thebutlerschool.org. And also be aware that I'm leaving out a lot of information to the point that this is a bit oversimplified, so don't take it too literally. Take it as a model that works very well. See you in the next video.